Dear Tim and Moby, please make a movie about the periodic table of elements. From Lauren. Sure. You're overreacting. It's not that complicated, really. The periodic table of elements may look complicated, but considering it's a list of all the chemical elements that occur in the universe, and then some, it's actually pretty simple. It categorizes elements according to the properties of their atoms. Atoms, you'll remember, are the smallest unit of an element. They're made up of a nucleus composed of protons and neutrons, and a number of electrons orbiting in different shells, or orbitals. It's the numbers of protons, neutrons, and electrons in an element's atoms that determine its properties. That's right, Moby. The configuration of these three particles is the only thing that makes one element different from another. The modern periodic table of elements organizes elements so that it's easier to see how elements relate to one another. Well, first off, the elements are listed by their atomic number, or number of protons in their atomic nuclei. You can find that here, along with the element's symbol, name, and relative atomic mass. You can read across the table this way. Hydrogen has 1 proton, helium has 2, lithium 3, beryllium 4, boron 5, and so on. Reading across this way, the sets are called periods. You remember how electrons orbit in shells, right? Well, periods describe the number of electron shells that elements have. Period 1 consists of only 2 elements, hydrogen and helium. These guys only have 1 electron shell. Period 2 contains elements with 2 electron shells. The first shell contains 2 electrons, and the second one can hold up to 8 electrons. As you read across a period, that outer shell fills up with electrons. So lithium has 1 electron in the outer shell, beryllium has 2 electrons, boron has 3, and so on. By the time you get to the far right side, the outer shell is completely full. The 6th and 7th periods contain so many elements, scientists took some out and put them underneath. Well, the configuration of electrons in an atom's outer shell plays an important role, too. It determines what other kinds of elements it can bond with. On the periodic table, elements with similar configurations of electrons are arranged in vertical columns called groups. Groups are numbered 1 through 18. In some of these groups, the elements don't have that much in common, but that's not always the case. Take a look at group 1. All the elements in this group have exactly 1 electron in their outermost shells. That means they're likely to form positive ions. They're also likely to bond with elements in group 17, whose outer shells are 1 electron shy of being completely full. The periodic table is also organized by color into different categories. These categories are organized by properties of the elements. Alkali metals, like sodium, all can react with water to produce alkaline solutions. Alkaline earth metals, like calcium, also produce alkaline solutions when combined with water and are found all over the place on Earth. Transition metals, like iron, are strong and shiny. Poor metals, such as lead, are soft with low melting points. Semi-metals, like silicon, conduct electricity only under certain conditions and are useful in electronics. Nonmetals have a variety of properties and include the carbon, nitrogen, and oxygen vital to life on Earth. Noble gases, like helium and neon, have outer electron shells that are full, and so they don't often react with other elements. So there you go, the periodic table of elements. Well, I've seen tables with elements going all the way